Okay, so we've got yet again another rational inequality, and let's take a look at it. It says 3x over negative 4x plus 4 is greater than or equal to 8. Well, this is nice, but what we need to do is have 0 on one side of the inequality. So the easiest thing to do here is to move this 8 to the other side, and I'm going to go ahead and do that. Okay, so let me go ahead and rewrite this over here. Let's see, 3x over negative 4x plus 4 minus 8. Okay, now the other thing we need to do is combine this. Okay, so I'm not going to write the greater than or equal to just yet. Well, I could write it. Let me just write it in. Greater than or equal to 0. Okay, now the next thing we need to do is combine these two. So in order to do that, think about this. We're subtracting fractions. What do we need? Okay, if you said common denominator, you're right. We need a common denominator right here. So the only denominator I see right here is the negative 4x plus 4. So I'm actually going to multiply this 8 on the top and the bottom by the negative 4x plus 4. There we go. We have that as our denominator, and now all we need to do is distribute. And then we'll combine some like terms. Okay, so let's work on the next line, and it says 3x minus, and then it's negative 8 times negative 4x, so that's actually plus 32x. And over here, negative 8 times positive 4 is negative 32. So there we have negative 32. And then, of course, the denominator for both is the same, and we keep that denominator, negative 4x plus 4. And remember that this is all greater than or equal to 0. All right, let's make the next step here then. Let's see. We now need to combine like terms, and we get 35x minus 32 all divided by negative 4x plus 4, and all of that really should be greater than or equal to 0. So there we have that. Now we've got a standard rational inequality. All we have to do is check, well, where does the numerator, where does the denominator equal 0? And we're going to use that to help identify what we call our test points. So let's take 35x minus 32 and set it equal to 0. And then we're going to take the negative 4x plus 4 and set it equal to 0 and solve for that. So here we're going to add 32 to both sides. All right, 35x equal 32. Divide both sides by 35. And x equals 32 out of 35. And right over here, we have negative 4x plus 4. All right, we're going to subtract 4. Okay, negative 4x equals negative 4, and we're going to divide both sides by negative 4. Okay, now here we end up with x being equal to 1. So we're going to next draw our number line. All right, so here's our number line, and we're going to have to pick a few test points. All right, but let's fill in the numbers that we're working with right now. First one is 32 out of 35, and the next one is 1. Okay, so we need to figure out some test points. All right, let's pick 3 test points. Let's draw our region here to kind of separate our work. And let's see. We can put in negative infinity, I guess. I'm going to put positive infinity there. We need something, let's say, before 32 35ths. Well, this, of course, is a number less than 1. So we can pick something less than that. 0 is a good one. So there's a good test point, 0. Now we need something after 1 as a good test point. So let's pick 2. So there's another good test point. Now we need something in between these two. Well, heaven knows what the decimal equivalent of this is, right? But an easy thing to go with is 33 out of 35, because that's right after 32. So 33 out of 35 is a good choice. Now all we need to do is plug it into this variation of the rational. Okay, so let's go ahead and do that. All right, so when we plug in 0, this one, the left side here should be very easy. 35 times 0 minus 32, all divided by negative 4 times 0 plus 4. So this ends up being, and remember we're checking, and I kind of went over space here. We're checking if it is greater than or equal to 0. So this becomes 0, this becomes 0. We're left with negative 32 divided by 4. And what's negative 32 divided by 4? Well, if you said negative 8, then you're correct. So what do we get? What do we get? Negative 32 divided by 4, negative 8, greater than or equal to 0. Is that true? No, it is not true. Okay? This is not true right here. Negative 8 is not bigger than 0. Now let's check this next one. All right, let's check the next one. All right, 35 times 33 over 35 minus 32 divided by negative 4 times the same fraction. Okay, we're checking if it's greater than or equal to 0. Okay, now this right here would cancel. We've got 33 minus 32, which is 1 on top. Okay, now this next part is going to give us a fraction. Okay, so let's see what the equivalent is there. Let's see. What is negative 4 times 33? It is negative 132 over 35 plus 4. Okay, so 132 over 35. It's, let's say, approximately about negative 3.77 if you wanted to give it a fraction. And obviously, this right here, the difference is just about, let's say, 0.23, plus or minus a couple digits. But it's a positive, so this is a positive number, and of course it's greater than 0. So this area would be an area of truth. So this part is good. Now let's check this right here. The last part, let's see here. 35 times 1 minus 32 over negative 4 times 1 plus 4 greater than or equal to 0. 35 minus 32, of course, is 3. And the denominator here, negative 4 plus 4, is what? Let's see here. Negative 4 plus 4, 0. Well, we know we can't even divide by 0, so we shouldn't even bother checking if this would even be greater than 0. So this part right here is actually not true either. So the area of truth is just this region in between right here. And because it's greater than or equal to, we're going to put the square bracket on either side, and we're going to highlight this region right here. Okay, so now all we have to do is write it in interval notation, and this graph makes it really easy to come up with the interval. It is 32 out of 35, including it with the square bracket, to 1, and then including the 1 as well with the square bracket. So here is our interval notation for this rational inequality.